Hello, I'm Clint Vance. Today we'll talk about fractions, mixed numbers, and rational expressions. Our specific objectives are to simplify fractions, write equivalent fractions, use less than or greater than or equal to make a true statement, and finally to write improper fractions as mixed numbers or mixed numbers. A fraction is a number that describes a part of a whole. For instance, the fraction 2 over 3, we say that the top number, 2 in this case, is what we call the numerator. In this case, the number 3, the number below the bar, is called the denominator. We say the denominator is the number of equal-sized division of the whole expression or the whole piece, while the numerator is just those number of equal-sized divisions that you are interested in that particular problem. For instance, let's look at some rules that talk about how to simplify fractions. Now, we say a fraction is in simplest form when it's equivalent to a given expression with the fewest symbols and the smallest numbers possible. Let's look at some of the rules that involve with simplifying fractions. If the denominator is 1, then the fraction can be simplified to the numerator. In this case, n over 1 would just equal to n. In particular, let's look at a fraction such as 5 over 1. In this case, since the denominator is equal to 1, it says this fraction can be simplified just to equal 5. Let's look at another rule involving simplifying fractions. If the numerator of a fraction is 0 and the denominator is any number other than 0, then the fraction can be simplified to 0. Again, we have the 0 over n equals 0 as long as n does not equal to 0. Let's look at an example. We had the fraction 0 over 9. Again, our numerator is 0 and our denominator is something other than 0. This fraction just simplifies to give us 0. Let's try look at another rule involving simplification of fractions. If the denominator is 0 and the numerator is any number other than 0, we say the fraction is undefined. Here we have n over 0 is undefined. Again, it says when n is not equal to 0. An example of this, let's take a fraction such as 5 over 0. Again, we notice that the numerator, again, is any number other than 0. The denominator is 0, so therefore we say this fraction is undefined. In the case where the numerator is 0 and the denominator is 0, we say that's indeterminate. So we don't have an answer for 0 over 0. Let's look at one more rule involving simplifying fractions. It says a fraction with the same numerator and denominator other than 0 can be simplified to 1. Again, we show it here, n over n equals 1 as long as n is not equal to 0. An example of this would be a fraction such as 4 over 4. In this case, we have the same numerator and denominator, so we say this fraction can be simplified to equal 1. Let's now talk about equivalent fractions. We say that we can create equivalent fractions by multiplying or dividing the numerator and denominator by the same number. For instance, here's the fraction 5 over 9, and we want to find, again, what number can we put here in the numerator to make this fraction equivalent to a fraction over 27. It says we can create this by multiplying the numerator and denominator by the same number. In this case, that same number, let's multiply the top and the numerator and denominator by 3. In the denominator, the 9 times 3 would give us the 27. In the numerator, the 5 times 3 would give us 15. Well, that tells us that the fraction 5 over 9 is equivalent to the fraction 15 over 27. Let's try another one. It says fill in the blank so that the fractions are equivalent. 21 over 36 equals to blank over 12. Stop the tape while you work on this problem. All right, let's fill in the blank. Here the fraction 21 over 36, we can reduce that by dividing the numerator and denominator by 3. Again, we said we can create equivalent fractions by multiplying or dividing the numerator and denominator by the same number. We chose 3 because the 36 divided by 3 gives us the 12, which is the denominator we're trying to find the fraction is equivalent to. So also in the numerator then, 21 divided by 3 will give us 7. So it says then that the fraction 21 over 36 is equivalent to the fraction 7 over 12. Let's now talk about comparing fractions. It says to compare fractions, we have a couple of methods. It says to compare two fractions, upscale or reduce both fractions to equivalent fractions that have a common denominator, and then we can compare them. Let's look at the following example. Here it says use less than or greater than or equal to make a true statement. We're trying to find the relation between negative 7 over 8 and negative 9 over 11. Now what we're going to do is give them a common denominator so then we can compare the numerators. In this case, we'll take the negative 7 over 8 and find the equivalent fraction by multiplying the numerator and the denominator by 11 over 11. So it tells us the fraction negative 7 over 8 is equivalent to the fraction negative 77 over 88. We'll also find the equivalent fraction for negative 9 over 11. We'll multiply the numerator and denominator by 8, which gives us the equivalent fraction of negative 72 over 88. Now they have the same denominator, we can actually compare the numerators. In this case, we want to remember that negative 72 is actually larger than negative 77. So since that's true, then that tells us that the fraction negative 72 over 88 is larger than the fraction negative 77 over 88. But we go back and recognize that the negative 72 over 88 was equivalent to the negative 9/11. So we can make a conclusion then that negative 7/8 is less than negative 9/11. Now they also have a second method that we can do the comparison, and this second method uses cross multiplication. So what we do in that case is cross multiply. So here we have 8 times, again, the negative 9, which gives us negative 72, and compare that again with the other cross product of negative 7 times 11. And again, we notice that negative 72 is larger than negative 77, and that would be the numerator when we upscale the fraction negative 9 over 11. So again, that tells us that fraction is larger. So even with the second method, again, we agree that negative 7/8 is less than negative 9/11. Let's now talk about improper fractions. An improper fraction is a fraction where the absolute value of the numerator is larger than the absolute value of the denominator. We want to talk about changing improper fractions into mixed numerals or mixed numbers. Let's talk about that. The procedure shows that to write an improper fraction as a mixed number, we first divide the denominator into the numerator. Secondly, we can write the results in the form, again, the quotient with the remainder over the denominator. Let's look at the following example. It says write the improper fraction as a mixed number, 30 over 7. Now what we're going to do here is divide 7 into 30. Now 7 can't go into 3, but 7 can go into 30 4 times. 4 times 7 is 28, with 2 left over. It says that the fraction, improper fraction 30 over 7 can then be written as the quotient, which was 4, and the remainder, which was 2, and again, keeping the denominator the same, 7. So it says that 30 over 7 is equivalent to 4 and 2/7, or that's the mixed number that's equivalent to the improper fraction 30 over 7. Today we talked about fractions, mixed numerals, mixed numbers, and we also talked about rational expressions. Again, keep practicing and good luck.